So now we have some data in our database. Let's go and see how we can get this data out of there and return it via our API endpoints. So what we'll do is we'll head back into our API, into our controllers, and we'll just continue to work with the values controller at this moment in time, because we're just trying to keep things as simple as possible. So we'll make use of this demo controller, and what we'll do is we'll inject our data context into our values controller, and then we'll have access to our context so that we can make queries to our database via Entity Framework and return the data from there. Now what we need to do to inject something into our controllers is we need to create a constructor. So I'm going to use the quick fix with my cursor inside values controller, and I'm going to say generate constructor values controller. And then what I want to do is add a parameter inside here, and I'm going to add the data context as a parameter and call it context. And we'll just need to bring in context from persistence. And what we need to do then is make a private field from our parameter here so that we have access to it in our class. And the way that we can do this, I'll just say initialize field from parameter. I'll use the quick fix again to do so. And this will create the read-only field inside our class. But with private variables, it's kind of conventional to have an underscore in front of the name of the variable. And VS Code doesn't do this by default. But what I can do is I can go into my settings, so I'm just going to go to Code and Preferences and Settings, and I'm just going to search for private. And in our C# extensions, we can add a private member prefix inside here, and I want this prefix just to be an underscore. So if I go back to my values controller, and I'll just remove what was added when we initialized our field, and I'll do the same again. I'll initialize field from parameter, and this time we get underscore context. Now we also have list underscore or list dot underscore context equals context. Now this operator is kind of redundant inside here, so we don't need to specify that this context is part of this particular class. We can actually just remove this as well, and I'll do so. But what we have now is access to our data context inside our values controller. And what we can do with this is, instead of returning these two strings, is we can return all of the values as a list from our database. So what we'll do is we'll keep this as an action result, and instead of returning an IEnumerable of string, we'll return an IEnumerable of value. And I'll just bring in the domain as well, so we have access to the value class. And what I can do inside here is I can say var values is equal to context.values.toList. And then, instead of returning a new string, what we can do is return OK, which is going to return a 200 OK response from our API, and I can pass in the values inside here. Now this will work just fine, but it's recommended, or the recommended approach is always to make any queries to our database, because they have potential to be long-running queries, is to always make them asynchronous. It's a very, very, very minimal performance hit to do so. And this also makes our application instantly more scalable, because when we make a request to our database and we make the method an async method, then this is going to pass the database query to a different thread, and it's not going to block the thread where this GET request is coming in on. So what we can do is, instead of saying just returning a public action result here, what we can do is return public async, and when we use an async method, we're going to return a task, and then we can wrap this around what we're returning here for our action result. What we can also do then is we can specify that we want to await the return of what's coming back from our database. But in order to use the await, we need to use an asynchronous method from Entity Framework, and toList is a synchronous method. So what we want to do is we want to use the asynchronous version of this particular method, and then we can bring in using Entity Framework Core so we have access to this. Now this is doing exactly the same thing as it was before, but instead of running the entire request on one thread, including going out to get our values from the database, this is now passing off the request to call our database onto a different thread, and then we await that task to be completed, but we're not blocking the request, the thread that the request comes in on. Now it's pretty simple to make our synchronous code asynchronous, and like I say, it doesn't incur a significant performance hit. So whenever you write a method that has potential to be long running, and any call to a database has that potential, obviously this is not going to be a long running request. We're going to get these values back very, very quickly. But like I say, it is the recommended approach to make things asynchronous where there's an asynchronous method available. So what we'll do is we'll also do the same thing for our individual value here, and we'll make this an asynchronous method as well. So we'll return a task, and we'll return an action result again of value, but this time not an IEnumerable of value. And then what we'll do is say var value equals await context, and we have options inside here. We can say context.values, and what we can do is say find async, first or default async, or single async, or single or default async. There's lots and lots of different methods to get values and query databases inside Entity Framework Core. Now probably the most appropriate ones to use here is to use either single or default async, and this is going to asynchronously return the only element of a sequence that matches a condition. Now we're going to query the ID of the value and bring back that particular entity from the database. And if we're using single or default, then what this will return is either the value if it finds it, or the default value for the type of object we're querying. In the case of value, it's an object, so its default value is null. And that's what we would get back from this. However, there's also another one we can use, and the one that's probably most appropriate here is to use find async. And this is going to find an entity with the given primary key values. And if it doesn't find the value by that ID, then it's going to return null. And because our ID is a primary key, we can actually use find async to see if our value, or to retrieve our value from the database. And we can just specify the ID inside find async, and this should return the matching value and store it inside this particular variable. And with this we can return OK, and then just specify the value. So with this in place, we're now ready to test the results of our actions, and what we want to do to test this is utilize a tool called Postman, which is a much better way of testing that our API is functioning as we want it, as opposed to using the browser. So what we'll take a look at next is introducing Postman to do so.